purpose of this film is to describe and explain the construction of the 24th Series Packard chassis and how it differs from previous models. First, we will describe the carburetor and fuel system. A new carburetor known as the Carter WGD type is used on all Packard Thunderbolt engines. Model 784S is used on the 200 engine. Model 767S is used on the 300 and Patrician 400 engines. In general, the WGD carburetor is similar to the previous WDO type, except it is somewhat more compact in design and is vented to the atmosphere. The WGD carburetor has 5 main systems: float system, main metering system, idle system, accelerating system, and climatic control. The fuel bowl is narrow and deep. The shape of the float is rectangular, and the float has a long pivot arm. The float, needle valve, and seat are located deeper in the fuel bowl. Thus, the needle and seat are somewhat longer. The bowl cover and air horn are cast in one piece. The fuel metering is accomplished by 2 tapered metering rods, operating in 2 main metering jets of a relatively larger opening. The effective opening of the jets is varied by moving the metering rods up and down in the jets. The main metering jets are located on a ledge in the fuel bowl. This arrangement permits a trap in the bottom of the fuel bowl to allow any small particles of dirt and foreign matter to settle in the trap without being drawn into the jets. The main metering rods are operated by a simplified and more direct linkage. The vacuumeter piston link has 2 integral arms that raise and lower the metering rods evenly and smoothly. The adjustment of the metering rods is simplified and requires no gauges. The main discharge nozzle has a closed upper end which extends into the primary venturi. The nozzle is permanently pressed into place at a 45-degree angle. The fuel discharge opening is drilled at right angle to the venturi. The main discharge nozzle passage is tapered and has a permanently open anti-percolating well, and the anti-percolator valves are eliminated. The anti-percolator well has a drive-in type jet. There is another small vent from the anti-percolator well to the idle well. This vents the anti-percolator well to the atmosphere during idle operation, but provides a balance between the anti-percolator well and the high-speed passage during high-speed operation. This balance practically eliminates any backbleed of air into the main metering system during high-speed operation. The idle system is similar to that of the WDO carburetor, except the location of the idle tubes, air bleeds, economizers, and bypass jets. The WGD idle tubes are threaded at the upper end into the lower side of the air horn. A hexagon nut below the threaded portion makes it possible to tighten the tubes. The air bleeds, bypass jets, and economizers are permanently located in the air horn. The sizes of these metered jets are fixed and should not be altered under any circumstances. A small bleed from the top of the idle well through a restricted passage into the anti-percolator well prevents the formation of vapors into the idle well, which would change the fuel-air ratio and produce an erratic idle at abnormal engine operating temperature. The idle passages extend down through the carburetor main body into the throttle body. 2 idle adjusting screws, 2 idle ports, and 2 low-speed ports to control the mixture at idle and low speeds are located in the forward side of the throttle body. The idle speed screw is located in the throttle shaft lever. Fast idle is accomplished by a lever and rod connecting the inner end of the throttle shaft with the choke valve shaft. Fast idle adjustment is obtained by bending the choke connector rod at the lower angle. The accelerating system is a plunger-type pump operated by the throttle, similar to that used on the WDO carburetor. A ball inlet check valve and a conical discharge check valve are used. Two discharge jets direct the fuel into the airstream of the carburetor. The jets are located in a pump discharge jet cluster, which may be removed for cleaning the jets. Prolonged action of the pump is accomplished by the spring-loaded pump plunger shaft. When the throttle is suddenly opened, the pump linkage and lever forces the pump plunger shaft down. This increases the spring load on the pump plunger, moving the plunger down as the fuel is discharged from the pump discharge jets. The accelerating pump linkage is simplified and direct. The choke valve is operated automatically by a thermostatic coil and a vacuum-operated piston. The thermostatic coil tends to close the choke valve when cold, while the vacuum piston tends to open the valve as engine vacuum increases. When the thermostatic coil warms up, it loses its tension. The climatic control is similar to that used on the WDO carburetor, except that the fast idle and unloader linkage is simplified and more positive. The WGD carburetor climatic control does not use a strainer, but uses a metal baffle plate to prevent dirt and foreign particles from accumulating in the slots of the choke vacuum cylinder. A starting switch, which is operated by the accelerator, is incorporated in the WGD carburetor. The carburetor throttle shaft has a milled groove, which, when turned, moves a steel ball operating the starting switch plunger. When the engine is running, the vacuum raises the ball away from the shaft and plunger, making the switch inoperative. The large capacity fuel pump used on the 24th Series Packard is a diaphragm type, actuated by a linkage and an arm operating on an eccentric of the camshaft. A fuel filter is incorporated as an integral part of the pump. An air dome is fitted into the outlet passage to eliminate pulsation and to provide a uniform flow and pressure. A vacuum booster is combined with the fuel pump. The booster helps to maintain constant vacuum for the windshield wipers when the engine vacuum drops during acceleration or heavy pulling. The new booster line connects the pump with the center of the intake manifold. This provides smoother engine idle during windshield wiper operation. The Packard 200 carburetor is equipped with a vertical type air cleaner. Its improved design and greater size help to silence carburetor roar. An oil bath air cleaner is used on the 300 and Patrician 400 for more efficient filtering of the air. An almost square fuel tank is made of two pieces of turn plate welded together. It's carried at the left rear of the chassis under the luggage compartment. The weight of the fuel balances the weight of the spare tire and wheel at the right side of the luggage compartment. The capacity of the fuel tank on all models is 20 gallons. An electric gauge sending unit is located in the upper side of the tank. The filler tube is equipped with a musical signal to prevent overfilling. The fuel line is mounted outside of the left frame side member to remove it from exhaust heat and prevent vapor lock. A flexible line connects the fuel pump with the steel line. The frame, which is the structural backbone of the car, will be described next. The 24th Series frame, completely redesigned, retains the proven ruggedness of X and H-type racing, yet provides new low-point mounting, which takes inches off the overall height of the 24th Series Packard. The heavy channel steel side members running the entire length of the frame are joined together by 4 heavy cross members and an unusually strong X member. All frame joints are either welded or cold riveted for greater strength. Extra strength, where it is needed, is engineered into the frame by use of sturdy box and U-type girders for cross members. I-beam type of construction is used for the X member in the area under the body compartment for maximum rigidity without unnecessary weight. A U-type member at the forward end of the frame reinforces the frame horns to assure a strong mounting for the front bumper, as well as a support for the radiator assembly. A welded box-type structure provides exceptional rigidity at the point of engine and front suspension support. In addition, the engine mountings are welded and bolted to double side rails, which extend rearward from this cross member to the forward legs of the X member. The cross member at the top of the rear kick-up is a sturdy steel U-type brace, providing exceptional strength for reinforcing the frame at this point and anchoring the rear shock absorbers. A Z-type cross member provides extra reinforcement for mounting the bumper and the gas tank at the rear of the frame. New outrigger body brackets are longer and sturdier and enable a perfectly balanced mounting of body to frame. This type of body mounting permits a lower overall height of the car. The combination of all the features of this reproportioned frame provides dependable strength, which can withstand great impact and endure the shocks and stress of long-term use. Now let's talk about a real feature, the Packard steering. The Packard Road Ease steering has been accomplished by new weight distribution and a new steering gear assembly for the 24th Series cars, which has been redesigned with a lower ratio to provide better control and steering that is almost effortless. One steering gear assembly is used for all models. Among the other changes, the new steering gear cross shaft is shorter. The case is shorter, and the mounting flange of the case has 3 tapped holes, which eliminate the use of retaining nuts and washers. 2 new steering wheels are used. The steering wheel used on the 200 and 300 is made of a steel core and molded rubber painted black. The steering wheel used on the Patrician 400 is made of a steel core and molded ivory plastic. The newly designed steering idler assembly has a steel bushing with a rubber core, which is pressed into the steering idler lever. It is attached to the idler bracket by a nut and washer. When the steering wheel is turned, the action on the bushing at the steering idler lever is soft because of a slight twisting force being exerted on the rubber core of the bushing. This results in quiet steering and the elimination of lost motion. Now let's see what changes are made in the new transmission. The transmission used on the 24th Series Packard is similar to that previously used, except that it has a longer, sturdier rear bearing retainer. This is necessary because the rear engine supports have been removed from the transmission case, and the rear end of the engine is supported by a single mounting under the rear end of the rear bearing retainer. The universal joint companion flange is attached to the rear end of the main driving shaft with a sliding fit. The rear bearing retainer has a Babbitt bearing, which supports the universal joint companion flange. The new transmission shifting linkage is similar to the 23rd Series, except that the new type relay mechanism has been relocated for smoother operation. The linkage relay shaft is attached to the top of the frame front side rail and the transmission bell housing. It's cushioned at each end by rubber cord bearing assemblies, which absorb and prevent the transfer of engine vibration or road shock to the steering gearshift lever. Movement of the transmission gearshift lever pulls or pushes a bell crank on the relay shaft, which in turn moves the transmission shift levers to the selected position. The 24th Series Packard Overdrive is similar to that previously used, except that it has a longer main shaft and a longer and sturdier case. The rear end of the engine is supported by a single mounting under the rear end of the overdrive case. The universal joint companion flange is attached to the overdrive main shaft with a sliding fit. The rear end of the overdrive case has a Babbitt bearing which supports the universal joint companion flange. The overdrive main shaft rear bearings are held in place on the shaft by a snap ring. The operation of the overdrive lockout switch, governor, kick-down switch, solenoid, wiring, and other overdrive electrical units is the same as that used on the 23rd Series Overdrive. The remarkable Ultramatic drive has had only minor changes since its conception. One important change is the addition of two circumferential grooves on each side of the direct drive clutch driven plate facings. This provides a more positive disengagement of the direct drive clutch when the vehicle is brought to a stop. The 24th Series engines are supported at the rear end by a single mounting. Therefore, the Ultramatic drive rear bearing retainer is longer and sturdier to support the engine on the mounting. The Ultramatic drive has an extension shaft attached with a slip fit to the rear end of the output shaft. The rear end of the extension shaft is splined, to which the universal joint companion flange is rigidly attached by a large nut and washer. The rear end of the rear bearing retainer has a ball bearing to support the extension shaft. The bearing is held in place between a shoulder on the shaft and the universal joint flange. An oil seal pressed into the rear end of the retainer keeps the oil in and dirt out. A new and convenient method of cooling the oil for the Ultramatic drive has been added to the 24th Series cars by making the Ultramatic oil cooler a separate unit. The new kidney-shaped oil cooler is held by a welded bracket to the engine timing gear case cover. The Ultramatic drive oil cooler lines have been relocated. They are now supported by steel clips along the left side of the engine crankcase. Since the lines and cooler are firmly attached to the engine, the need of flexible cooler connections has been eliminated. The lines are connected securely to fittings in the transmission case and the oil cooler. The universal joints and propeller shaft used on the standard transmission and overdrive equipped 24th Series cars are of the cross type and are interchangeable. The slip joint is between the flange and the transmission or overdrive main shaft. It may be noticed that the propeller shaft used on two cars of the same model may differ slightly in construction. This is because they are supplied by different manufacturers. In servicing the propeller shaft and universal joints, always replace the parts with identical new parts supplied by the same manufacturer. On Ultramatic drive equipped cars, a ball trunnion joint is used at the front end and a cross-type joint is used at the rear end. There is no slip joint provided, since the ball trunnion end will compensate for length variations. The differential pinion flange has been eliminated by attaching the universal joint rear yoke directly on the pinion shaft splines. The 200 uses the same front and rear hub and drum assembly as the 2301. The front drum assemblies of the 300 and Patrician 400 are 1/2 inch wider than previous models, since 2 1/4 inch brake lining is used. The rear drum assemblies are 1/4 inch wider than previous models, since 2 1/4 inch width brake linings are used on the 300 and Patrician 400. The most noticeable difference on 24th Series wheels is the absence of spring clips for attaching the hub shell covers. The wheels used on the 200 now have 3 raised lugs for attaching the hub shell covers. The wheels used on the 300 and Patrician 400 do not have lugs, as they use a larger hub shell cover, which grips onto the step of the wheel rim. 3 hub shell covers are now used on 24th Series wheels. The 200 uses a steel, semi-spherical shaped hub shell cover with the word Packard embossed in the center section. It is similar in size to previous covers, but attaches in an entirely different manner. The hub shell cover is pressed over the evenly spaced lugs. The spring tension and the beaded edges of this cover hold it firmly in position. The 300 uses a larger stainless steel hub shell cover of the disc type, incorporating the features of a trim ring. It also has the letters Packard embossed in the recessed center section of the hub shell cover. This cover has 8 raised flanged edges, spring tension, and evenly spaced around the outside edge, which grip the step of the wheel rim with a claw-like effect to hold it in position. The Patrician 400 uses the same type cover as used on the 300, except a cloisonne emblem is attached to the center section of the hub shell cover. Wheel trim rings are standard equipment on the 200 deluxe wheels. They are also available for the 200 as an accessory. The design of the hub shell covers on the 300 and Patrician 400 wheels makes the use of wheel trim rings unnecessary for these models. The tire sizes are 760/15 on the 200. The 300 and the Patrician 400 use 800/15 tires. The wheel rim size is 15-inch by 5 1/2 inch on the 200. The rim size is 15-inch by 6-inch on the 300 and the Patrician 400. Yes, the 24th Series Packard is by far the finest Packard ever built. Its performance, safety, comfort, and engineering refinements surpass any previous Packard model. But the satisfaction the new Packard owner will obtain from this fine car will greatly depend upon the quality of service by Packard servicemen. Therefore, to be sure that you render the kind of service this fine car rightfully deserves, study and apply the information contained in these films and in the Packard Serviceman's training book entitled Know the 24th Series Packard.